this is just meant to be a demonstration of some of the grade penalty computational work that we're doing in working group 1 and project 1. And so I have a couple pieces of code here that do some things that we're interested in doing in the working group. One of them is what we've been calling grade penalty, or grade penalties for different groups, meaning how different is the grade you got from the grade that we would have expected based on your GPA and your other classes. So I've uploaded this code to GitHub, and just quickly the file structure here. This is what it looks on GitHub. So there are two main functions here. One's called the grade penalty working group P1 function, and this other one is just a big file full of functions. And so I open those up here in RStudio. And so the main workhorse here, the main, I guess the front end of this is the grade penalty working group file. And then over here is this thing that's full of functions. And you can open up and look at it. And I mean, we'll want to get into that and take it apart a little bit as we decide to do different analyses or run different analyses. And so this is all set up to run on one course at a time. Okay, so one course and actually one term of a course. So I do have modifications to run on all terms of a course, but let's just stick with the one course right now. And so what it's going to do is take one course at a time, take these student course and student record tables that are defined according to this data model that Becky and Stefano put together. So the names, the conventions, I think are all consistent with that. So it takes those two inputs, those two tables as input. You have to select the course according to this course name here. You have to select the course term, so the term that you want to look at the course at. So the outputs then are 4 plots, but they show mean grade versus GPAO in a class, and then 4 different breakdowns of demographic groups. So it makes those plots. That's the first thing it does. And I'll put them over here in this plot window. The second thing it does is it returns a list. And so it's a list of tables, right? So this is a list is a strange object in R. It's just a variable where you can dump all these different things in. So to return that list, and it's just some more statistics by different groupings of students in that class. So down here I have some examples of how I run it. And then if you haven't sourced the grade penalty functions script, you want to do that, right? So I can do that here because I have the source unsaved thing selected. Okay, so I do that. And now I'm just going to cut and paste the exact example I have up here. And the only thing I'm going to change is I'm going to change these variable names to SR1 and SC1. The names don't matter specifically. I just renamed them that way in the particular session I was running in here. So I do that, I hit enter, and it usually goes pretty fast. So you can see here so suddenly there are these 4 plots over here, right? So here's a low income plot. So you can see for Physics 140, this is looking at low income versus high income students. The mean grade versus their GPAO. So this is a bin GPAO. It's color coded for the different groups, and it just fits a simple regression line to those two groups. And this is just more for, more for guiding your eye. There's no strict analysis going on there. And then if I flip back through here, you can see I have similar plots for first gen, for gender, and for ethnic code, right? So these are 3 different sort of ethnic codes that we defined that are in the data model, right? So it makes those. And now you can see here when I ran this up here, I defined this variable KK where I dumped out these 3 tables in a list. And so the way I access those elements of the list is with closed brackets, these closed square or 2 closed square brackets like this. So I can print them like that. I can also, if I actually see them a little bit more fully, I can do view, and you can see over here. So literally number of females, number of males, number of gender unknown, number of NAs, and then the number of ethnicity 0, number of ethnicity 1, et cetera, all the way over here, right? The second list that it makes are these lists, so these groupings by the Molinaro, what I'm calling the Molinaro analysis, where we go in and look for students that are first gen and low income, and then low income. So these are all mutually exclusive groups, right? So you can see there are only 2 students in this particular term of Physics 140 that were triples. So first gen, low income, and URM, right? And so for each of those groupings, we have mean grade, standard deviation, median absolute deviation, and then mean, standard deviation, median, and median absolute deviation for the grade anomaly, right? Grade minus GPAO. So those are for the different groupings. And then, another characteristic of that analysis is to go in and compute the number of, they call these a number of opportunities, right? So the 3 opportunity group all the way down to the 0 opportunity group. Again, in the same statistics for that group, for those groupings. So those are some things to look at for a particular course. That's by the Molinaro groupings. Another way we did it were by this non-mutually exclusive groupings. These are from, I'm calling them the Fiorini groupings because Stefano is the one that brought them to my attention first. And so these are non-mutually exclusive. So you can be both first gen and female and first gen, right? And so we can compute that. And so these just turn out, the way we do the analyses with these 2 different groupings is different, of course, and it aids in the interpretation. But it gives you the same output, right? The N, the mean grades, grade anomalies, all that stuff. And this is for an individual course. So that should give you enough to play around and to look at a few courses